Hello students. In this video we're going to look at question number 2 on page 81 of your course package. It states that a population is normally distributed with a size of 650 people. The population has a mean 6.5 and a standard deviation of 1.25. If a random sample of 70 is chosen, determine the probability that the sample mean will be between those two values. So we are trying to get a probability answer here. So let's go to our white screen. Let's write down what we know. The first thing that the question states is that population has a size of 650. Capital N population size does not usually show up in questions. When it does, it means we have to do one minor adjustment to the standard error, as we'll see. The population mean is 6.5. This population standard deviation is 1.25, and the sample size is 70. If we draw out this distribution, help us understand what we're trying to get at. The average is 650. 6.5 I mean, and we want to calculate the probability that it is going to be between this value of 6.3 and this value of 6.7, and this is what we're looking for, that combined area or probability. So the first thing we should calculate is our standard error. The standard error formula looks like this: the standard deviation divided by the square root of n. But as I said, whenever we have this value here, we have to apply what's called a finite correction factor. And it looks like this: population size n minus sample size little n over population size minus 1. So let's use this formula to apply to calculate our standard error. So the population standard deviation is 1.25, sample size is 70, and we want to multiply it by the square root of 650 for capital N minus 70 for small n for our sample size. So we're going to get a value of 580. 650 minus 70. And then we're going to get a value for n minus 1 to be 649. What I would do applying this in your calculator is to do both parts separately. It's just do this part, write down the answer, then do that part. Common error is to not take the standard deviation of everything underneath that. So when we apply that formula, we get a standard error of 0.141. So we need that standard error to help us calculate the z values to get the area and our final answer. So let's look at a new page. So one second. Before we move on, as I said, anytime you have population size, we're going to have to apply this population correction factor to our standard error. Okay, the question wants us to calculate the probability that it is between this probability of the sample mean being between 6.3 and 6.7. So we're going to use this formula once again: z equals the sample mean minus a population mean divided by our standard error. So the sample mean is 6.7 minus population mean of 6.5 divided by what we previously calculated as our sample mean, 0.141. And we'll get a z value of 1.42. When we do this for the other end of the distribution, same formula. We work with the value of 6.3 though, minus 6.5, and you can see that the z value will be negative because the difference from 6.7 to 6.5 is the same as 6.3 to 6.5. Our Z value is the same, only that it's negative, so it's negative 1.42. Second step is to find the area corresponds to a value of 1.42. To do that, we go into our normal distribution chart. 1.42 is right there. So you got 1.4 and a decimal of 0.02 gives us an area of 0.4222. So the area, and that's going to be the area for both of them. So we can add that area again, or we can multiply it by 2 to get our final answer, which will be 0.8444, or 84.44% probability of any sample mean of size 70 should be between 6.3 and 6.7.